Hello everyone, welcome back again to Excellent Solutions, a guide to score 300 plus in Jamb. Today we are going to be discussing physics and the topic is terms associated with wave motion. So if you are watching this video on any channel, kindly click on the like, share and subscribe to my channel so that you will be notified whenever I post a new video. Our question 1 of today says, for the wave motion represented above, the wavelength is given by, so we look at the wave motion, or this wave motion, we said wavelength is a distance between successive crests or successive troughs. So we have a crest here, we have trough here, So the distance between crest to crest is a wavelength, trough to trough is a wavelength. So if we look here, we only have S that defines distance between crest to crest. So the answer, the wavelength here is represented by S. And in the options, we have option D that says S. So the answer here is option D. So our next question is question 2. And this question says, the wave motion above has a frequency of, so this, if we look at this case, we have the motion start from here to this point. When it comes here, it makes 180 degrees. That is between north to another north. When it comes to here, it makes 360 degrees, which is the same as the number of revolution n is equal to 1. At this point, it makes 1 revolution. And the time taken to make 1 revolution is called period. So at this point, we have the period. So t equals to 0.2. So we have our t equal to 0.2. Remember, the frequency of a wave is reciprocal of the period. So we have F equals to 1 upon t, and this is the same as 1 upon 0.2. So we look at this 0.2 is the same as 1 upon 5. So this now becomes 1 upon 5. So here, if we take reciprocal, we are going to have 1 upon 1 times 5 upon 1, and this gives us 5 Hz. So our frequency is now equals to 5 Hz. So if we look at our options, option C, we have 5 Hz, and the answer is option C. The next question is question 3, and says the diagram above represents a transverse electromagnetic wave traveling with a speed of 3 exponential 8 meters per second. What is the frequency of the wave? So we have our velocity given as 3 exponential 8 meters per second. And we are asked to find the frequency, F. So if we are to find frequency, we know that the frequency of a wave, F is equal to V upon lambda. But we don't have the wavelength here. So one thing that we need to look here is that here we have, from here to here, this object makes 1 wavelength. To this point, it makes another wavelength. To this point, it makes another wavelength. So we are having 3 wavelengths, 1, 2, 3. And this 3 wavelength is the same as, from here to here, it says 0.3. So we now have 3 lambda equals to 0.3. Therefore, if we divide this by 3, we are going to have lambda, and we can say lambda is equal to 0.1 meters. So if we have lambda equal to 0.1 meters, our frequency here, we said F is equal to V upon lambda. So we now have F equals to V upon lambda. And this is same as having 3 exponential 8 divided by 0.1. So this now becomes, we can now say F equals to 3 exponential 8 divided by this one. If we take it in standard form, we are going to have 1 times 10 raised to the power of minus 1. So, and this is now the same as having 3 divided by 1. We can now say times, if this our exponential go up, this minus 1 go up, it becomes plus. So this becomes times 10 raised to the power of 8 plus 1. and this now becomes F equals to 3 times 10 raised to the power of 9 hertz. So if we look at our option, we have it in option D, 3 exponential 9 hertz, and the answer is D. The next question here is question 4, and this question says calculate the wavelength of light traveling with a speed of 3 exponential 8 meters per second. So we have V equals 3 exponential 8 meters per second and a frequency of 6.2 exponential 14. F equals to 6.2 exponential 14 hertz. Okay, we have to calculate the wavelength. We are looking for lambda. So if we look at this here, we say lambda equals to V upon F, and this now becomes 3 exponential 8 upon 6.2 exponential 14. So this now becomes, you can now say lambda equals to 3 is set upon 6.2. You can now say s times 10 raised to the power of 8. If this 14 goes up, it now becomes minus 14. So if we now divide 3 by 6.2, we cannot have a whole number. So we can now say lambda equals to, we have 0, put our point at 0 here, becomes 30. 30 divided by 6.2, this one we can make it as 62. So if it becomes 62 exponential minus 1. So this one, if we now divide this, we can 30 by 62, we cannot have a whole number. So we put a point and add 0 here. So 300 divided by 62, we have 4. Then remainder 52. So if we have remainder 52, we now add 0 to it. 520 divided by 62, we are going to have 8. And if we look at this exponential, we have times 10 raised to the power of 8 minus 14. We have 8 minus 14, we have minus 6 plus 1. So this now becomes lambda equals to 0.048 times 10 raised to the power of minus 5. So if we now have minus 5, we check this point. 1, 2. So this now becomes lambda equals to 4.8 times 10 raised to the power of minus 7 meters. And if you look at our option, in option B, we have 4.8 exponential minus 7 meters, and the answer is option B. The next question is question 5, and this question says in the curve above, PQRS represents an alternating voltage of frequency 50 Hz. The time interval between point P and R on the graph is, so we look at this. When this object starts from here to here, the number of revolution n is equal to half, because here we are having 180 degrees. At this point we have n equals to 1. So the number of revolutions between point P and R is equal to half. So we are looking for, the question asks us to find time interval between point P and R. See, F is equals to n over t. So if we make t the subject here, we now have t equals to n over f. And looking here, our number of revolution, n here is equals to half, which is 1 upon 2, divided by our frequency given in the question, f equals to 50 Hz. So we now divide this by 50. So this is the same as 1 over 2 times, we take reciprocal 1 over 50. And this now becomes 1 upon 100 seconds. So the time interval between point P and R is 1 upon 100 seconds. If you look at our options, option C we have 1 upon 100 seconds. The answer is option C.